Greetings and welcome, friends. We've made it to our section 8.5 using Intercept form. Intercept form. You've already graphed quadratic functions written in several different forms, such as f of x equals ax squared plus bx plus c, known as standard form, and g of x equals a, parentheses, x minus h all squared plus k, vertex form. Quadratic functions can also be written in intercept form, or f of x equals a, parentheses, x minus p, times parentheses, x minus q, where a is not equal to 0, all right, because otherwise then it's just like going to be a horizontal line. In this form, the polynomial that defines a function is in factored form. Notice this is factored. All of these are written as the product of expressions, and the x-intercepts of the graph can be easily determined. Hoorayness! So, here is Intercepts form. Wow. I'm already thinking about vertex form, sorry. And it turns out the x-intercepts are just going to be p and q, and it's just going to be the opposite of the number with the x in both of those cases. The axis of symmetry is halfway between p and q, right? So here's those x-intercepts there. I also want to point out I don't know where the y-intercept is based on this form. But if I multiply it all out using FOIL and distributive property or whatever, I could end up, my C term, my last term in standard form would give me the y-intercept. But notice halfway between, right, halfway between, is going to be the x-coordinate of the vertex, which, here's the equation of the axis of symmetry. You could also say that h, the x-coordinate of the vertex right here, actually I'll just write it down here. So here's our vertex. You could say that the h for the vertex is going to be the average, right, where you add them up and divide by how many there are. P plus q divided by 2. Quantity divided by 2. Add them up and then divide by 2. Don't divide just q by 2. That wouldn't work. The graph opens up or down when a is greater than 0 and when a is less than 0. So let's see what we can do to do. So let's do example 1 here, shall we? You guys already have this on your sheet, right, Tyler? That's right, Mr. Waddy. That is right. Example 1. Having fun. All right. So, actually, here we go. We've got my giraffe. Oh, they're asking for domain and range. I'll have to make sure I actually do that and not just graph it, because sometimes it is graph, and I'm like, I'm done, I'm out, and that's not actually the case. So let's see if we can figure this out. A is going to equal the -1 here, little invisible 1 hiding there, like a hobbit wearing a ring. I guess I'll label these with orange for P and Q. P is going to be -1, and Q is going to be +5, because I often reserve yellow for my other problem, you know, my work colors. So let's see. So let's plot our x-intercepts at -1, 0. Example 1. And +5, 0. Right, like that. All right, so I can plot those points. Which way does this open? Down, because a is negative, right? So I'm expecting that it opens down. And I can find h by doing p plus q divided by 2. P plus q divided by 2. H is going to equal -1 plus 5 all over 2, which is 4 over 2, and that's just equal to 2. So there's my h. H. All right, so I know that. I also know the axis of symmetry now is going to be just x equals 2. So I could find 2 here and draw that line. So I'm looking for an upside-down parabola that happens to have those intercepts. But there are infinitely many points that this could be, right? I could have like a parabola with a vertex here, like that. I also could have had a parabola with a vertex up here, and like that. There's actually infinitely many parabolas that would pass through those points and have h as this vertex, depending on how smooshed or stretched it happens to be. So I'm going to need to find k, And you guys perhaps remember that you can find k by doing f of h. So let's do that. I might run out of a little bit of space here. So I'll have f of 2 is going to equal -1 parentheses h is 2, so 2 plus 1 times parentheses 2 minus 5. Right, I just plugged in h for both of those x's. Right, you guys agree that makes sense? And if I plug in something for x, I will find its corresponding y value. So I'll have -1 parentheses 2 plus 1 is 3, and 2 minus 5 is -3. -1 times 3 is -3 times -3. Oh, positive 9. So that's going to be my k. Okay. So my vertex is at 2, 9, pulling from the h and the k. So over 2, up 9. There we go. Now, I think I actually might have misinformed my class earlier, claiming that the slopes would work for the A. Let's just test that. That would suggest that I could go down 1 and over 1, and down 3 and over 1, and down 5 and over 1. Oh, it does seem to work. We'll have to continue to experiment to see if that'll work for the other ones. Aha. Interesting. Interesting. But if I wanted points other than the x-intercepts and the vertex, I could plug in another value into the function f, like f of 1, and found out that its height was going to be 8, is what I could have done. Could have done. So let's do another problem here, friends. I can do math all day, and it's great. Having fun with my friends, doing math. All right, I'll work on the song. Wow, come on. Where has my little dog gone? Oh my goodness. I was trying to never mind, I don't think I have a good way to explain it. By hitting enter enough, I was trying to shift this so it would all show up in one table in my notes that I pull from my extended monitor, but I'll just have to copy and paste this in 2 chunks. Yep. I'll get it there for us. Just a second. All right, this one will be good. Oh, you know what I also didn't do? I didn't tell us domain and range. Classic Waddy, right? Classic. I'm just like, there's the graph, I'm out! And then drop the mic and I'm gone. All right, so there's the graph. Let's actually answer the question about domain and range. So the domain is everything, instead of all x such that x, every x value. All right, I could plug in -1 billion, I could plug in pi, I could plug in a Google, and I could get a value back for that. The range, however, the y values never get bigger than the maximum, which was 9. So I'm going to say that the range is the set of all y such that y is less than or equal to 9. Right? So that is my range. Right? Sip of coffee here. This is actually yesterday's coffee, but does the trick. Although my brother told me he had a professor that claimed that coffee molecules, the caffeine, would break down in 4 hours after it was brewed, and he would literally dump out a bunch of coffee if it was more than 4 hours old and make a new pot. I'm not a chemist, but I'd be interested in whether it doesn't feel accurate. I won't get caffeine withdrawals by drinking my day-old coffee right now. You know what I'm saying? You know what I'm saying. Also, exponential functions would help you in modeling the effectiveness of caffeine in your body over time. All right, here we go. Oh! Question, friends. Is this in the form that I need? Is this in Intercept's form? It isn't. I need to factor it. So watch this. Here we go. Let's factor out a 2 first of all. Whenever I factor, the first thing I should do is use GCF. So I'm going to have f of x equals 2 parentheses what? 2 times what, Tyler? What are you thinking here? 2 times what would be 2x squared? I would need a... Well, 2 times 1 is 2, and then I would need the x squared hanging out. And 2 times what would be negative 8? 2 times what would be negative 8? Or I could ask 8 divided by 2 is what? That's going to be negative 4. Now, this is still not factored. X squared minus 4, don't know if you guys remember this. A squared minus b squared is equal to a plus b times a minus b. Right? This can be factored, in which a is x and b is 2. All right, I get these by square rooting those values, ignoring the sign. And so this is now going to factor to be f of x equals 2 parentheses, and I'm going to have, remember, these are not conjugates, or sorry, these are not opposites, these aren't the same, they're called conjugates. Wow, I just completely messed up my line, but that's fine. So it's going to be x plus 2 times x minus 2. All right, so, Micaiah, what do you think A is now that this is in vertex form? Yeah, A is going to be the 2. And Micaiah, do you think that's going to open up or down for us now? It opens up, right? Because that's a positive, so it's opening up. And then let's see, then we've got P and Q. Brandon, what do you think P is pulling from this factor? Here, we'll compare it to this one. Right, it's the opposite of that number with the x. So it's going to be negative 2 for us here, and then this one's going to be positive 2. Turns out, even if you were wrong, you still would have gotten the same points, because this one would have given you the negative that, right? So it was actually almost like you can't get it wrong. So let's plot our x-intercept. So negative 2 is right there, and positive 2 is right there. I'm expecting this to open up, so I know the vertex is less than that, but like I said, there are infinitely many parabolas that satisfy that condition. So let's see what h is, and h I can find by doing p plus q divided by 2. And so let's figure that out. So h is going to equal negative 2 plus 2 divided by 2 is 0 divided by 2. And I'm going to get h, what's 0 divided by 2, friends? Zero, right? If I'm dividing by 0, it works out. So, and notice visually, the axis of symmetry is also going to be x equals that h value, that 0. And visually, right, this is exactly halfway between, man, my line is getting further and further from the truth. Halfway between my x-intercepts, and that's exactly what I would expect, because parabolas are mirror images of themselves, and the x-intercepts would have been mirror images over that mirror. So if I want to find, if I had the two x-intercepts and I'm like, where is that mirror? It's got to be halfway between them. So that's h. If I want to find k now, that's going to be f of h, right, Tyler? Right, Mr. Wally. So let's do f of h, so that's going to be F0. Great video game for the Super Nintendo about hover car racing. Let's see, I'll have plug in 0 for x up here and here. So I'm going to have 0 plus 2 and 0 minus 2. I do want to point out, when I'm plugging in h, I could plug it into this version, or even this version. Technically, either of those work. I think the factored form that I picked, the intercepts form, is probably easier, but I wouldn't say you're wrong for choosing another one. 0 plus 2 is 2. 0 minus 2 is negative 2. And let's multiply this out using PEMDAS. So f of 0 is equal to 2 times 2 is 4 times negative 2. f of 0 is going to equal -8. So therefore, k is equal to -8. 8. So let's plot that vertex. So 0 down 8 right there. Like so. Now, I want to test, will my slopes quote unquote trick work? Let's test this, because I'm not 100% convinced it will yet. Let's see. Because I love it when my slopes trick works, right? Slopes are the best. So normally I would have gone up 1 over 1, up 3 over 1, up 5 over 1, etc. And I now would have to multiply these by the a value of 2. Let's see. I don't know. Oh, guys, I think it's working. Guys, I would be so happy if it worked. I think it's going to work. The slopes are alive. All right, here we go. So from here, if I went up 2 over 1, I would have landed there. And then I would go up 6 over 1. And guys, where do I land? I land on the point that I already knew I had. What? Guys, good news. The slopes still work. And then I would have gone up 10 over 1 from there. So yeah, so I just found some other points without making a table of values. Table of values is the worst way to graph. You can find things out using a table of values, but it's the least fun in my mind. Right. I'd rather kind of understand the graph and its nature and then be able to make predictions from it and understand its general formation to be able to yeah, that's fine. There we go. Man, look at how weird my H's look upside down. Like right there. Look at that. Yep. That's true. Yeah, or they can watch it in fast forward and with subtitles. Pretty good. Yeah, well, I can pause here for you. What do you need? Here we go. We'll take a minute, internet friends. So I'm going to walk around, see how people are. You got it. Beep, beep, beep. Yeah, if while we're waiting, yeah, let's have us, you could try, monitoring progress question. Well, I've got That's right, class. There's yeah, leaks in our ceiling. Hey, internet friends, I'm back. I think I want, or wait, do I still have a window open of Desmos? Hey, I do. What do you know? Let's close this down. Shut it down. Can I just like zoom it back into normal? Here we go. Watch this. Let me let's look at an example. Man, why is that not showing me? There we go. All right, my bad. All right. So let's actually model this. So y equals a times x minus p parentheses times x minus q, right? Is our model. And watch how cool this is. I can hit add slider. Boop. And then now I can actually make a graph that gets modified by this, which is so cool. And then right, so you can see, oh my goodness. What is going on there? Guys, what is that changing? So notice this point is staying the same. Here, let's actually plot that. We'll plot the point p comma 0 and comma q comma 0. So we'll plot those points. Notice that this x-intercept is staying the same. It's changing the location of the other one. Isn't that weird looking? And the vertex is always halfway between those. And in terms of the steepness, watch this. The x-intercepts are never changing when A changes. It looks like it's jump roping. What's a cool jump rope song? Bubblegum, bubblegum in a dish. How many pieces do you wish? 1, 2. No, anybody know that? No one knows jump rope songs. And look at this. As far as the slopes, when I make A2, it is in fact going. Oh, is it? Oh, wait a minute. That's hard to tell because let me get this on a solid number. Oh, that's actually weird. Okay, let me get it on 2 even numbers or 2 odd numbers because then its vertex is actually at a half point. So let me put this at like 5 and -1 or something like that. So now its vertex is going to be halfway between that, which is at 2. But I'm interested in, is the A slope working correctly? So up 2 over 1, up 6 over 1. It's working. How great is that? I love it. Let's change A to 3, and let's see if A still works. All right. So this is going now up 3 over 1, and then up 3 times 3. It should go up 9 from there, landing us at -15. Up, yeah, over 1 right there. And then it would go up 3 times 5, so it would go up 15 from there, and the vertex is actually going to land. Man, that's awesome, guys. Good news. The A works. Our slopes still work. Aren't you happy about slopes? I love slopes. Slopes is the best. And I can make like a super shallow parabola, but it'll still like pass through those 2 points, no matter how I slide it around. Isn't that cool looking? The vertex is changing, right? But the x-intercepts are predicted successfully using that. All right, so that's good to know. All right. So you guys tried monitoring progress question 3. Want me to go over that one? Ooh. Let's do it. Ah! I rotated it instead of translating it. All right, so here's question 3. I'll cruise through this. You guys gave this an attempt. So first of all, it is not in the form we need. We need to factor it. And the first thing I'm going to do is factor out the A. Here we go. H of x is equal to 4 times parentheses x squared minus 9. When I factor that out, I would then end up, hey, this can be factored. Not all the time are these going to be difference of squares patterns, but in this case it is. So I'm going to factor it like that. And the question is, what would A and B have been? Well, A would have been x, because x squared is x squared, and B would have been, what squared is 9? What squared would give me 9? 3, yeah. So that means the factored form of this h of x is going to equal 4 times x plus 3 times x minus 3. Let's figure out our a's. A is 4. It opens up because it's positive. P is going to equal -3, and Q is going to equal the opposite of that, which will be positive 3. So here's -3 x-intercept. Here's positive 3 x-intercept. Halfway in between is 0. I'll just, quick speedy graph this. So h is going to be halfway between those, which is 0. K I could find by doing f of h, or 0 in this case. So what is f of 0? That's going to be 4 times 0 plus 3 times 0 minus 3. Do you guys get some of this so far? -36. Good thing I made my graph go far low as I did. So f of 0 is that. So k was equal to -36. So 0, -36. These the y scale is counting by 2s. So down 30, -32, 34, 36 is right there. And my slopes, now that I feel like I've got some with confidence, if a is 4, my slopes are going to be up 4 times 1 over 1, up 4 times 3 over 1, up 4 times 5 over 1, etc. So 4 over 1, 12 over 1, and 20 over 1. Let's see that. So going up 4 from here, remember my scale is counting by 2s, over 1, and then up 12, my bad. So I'm at 32, going up that is going to bring me to -20 over 1, and then going up 20 from -20 is going to bring me all the way to the x-axis. So, and then let me draw this parabola. Parabola. Oh man, you guys getting dizzy? You guys are getting good at graphing parabolas, is what you're getting. Not bad, not bad. Okay, so there we go. I think we're good. Thanks for watching, internet friends. You guys have a great day. Bye-bye.